Why is computational domain important for CFD? Imagine trying to understand how water flows around a boat or how air moves over an airplane wing. Without knowing the space where these flows happen, your results could be way off. That's where the computational domain comes into play. It is the specific region of space where the fluid flow simulation takes place. Think of it as the virtual sandbox in which all the action happens. When using computational fluid dynamics software, setting this space correctly is key to getting useful results. If the domain is too small, you might miss important flow features like turbulence or wake effects. If it's too big, you waste time and computer power on areas that don't matter. The shape and size of the space must include all relevant parts of the flow, whether it's outside a car or inside a pipe. For external flows like airflow around a vehicle, the domain extends well beyond the object to capture how the air behaves for a way. For internal flows inside a duct or a pump, the domain is confined within the boundaries of the system. Once the domain is set, it is divided into small pieces called a mesh. The quality of this mesh affects how accurately the software can solve the fluid equations. Finer meshes are needed where the flow is complex, like near walls or in turbulent regions. Proper domain definition helps target these areas for finer mesh, saving computational resources. The domain also defines where boundary conditions are applied. These are the rules that tell the simulation how the fluid behaves at the edges, such as how fast air enters or pressure leaves. Setting these correctly ensures the simulation mimics real-world conditions. For example, in designing an aircraft, choosing the right domain helps predict lift and drag accurately. In heating, ventilation, and air conditioning systems, it helps model airflow and temperature distribution inside rooms or ducts. Overall, the computational domain shapes the entire simulation. It determines what you include, how detailed your mesh is, and how realistic your boundary conditions are. When done right, it balances the need for accuracy with the limits of your computer's power. Properly defining this space is essential for trustworthy CFD results that support good design and analysis decisions in mechanical engineering.